Okay. So on Monday we were talking about functions, and hopefully you got a little bit of more of an introduction from lab yesterday. On Thursday or tomorrow, you'll start by writing your own small little library with a few functions for Hack 5, which of course is due on Friday, like all hacks are. Also another reminder that homework 3 is due Friday of next week, right? Yep. So if you haven't already started on that, I would highly suggest that you do. It covers loops, which we've more than covered at this point. You can write functions if you want for assignment 2, but you're going to have to keep them in the same files, and those instructions are in there. But everything that you need for homework 2 has been covered as of last week, so you should start getting work on it right now if you haven't already started. So we went through how to define functions. That is, you have a prototype, which basically declares the function signature. That's the 3 components: the return type, the name of the function, and the inputs to the function, the parameters to the function. Then later on, you provide a function definition. And then we also went through a demonstration of how to separate those out into separate header files, source files, and how to use those. And you'll be doing that all again next week in Lab 6, as well as on Hack 5 here. I now wanted to get into some other miscellaneous issues. We have a new keyword here. Actually, it's not new. You've seen it before, but it's void. So what is void? In plain old English, what is void? It's a bottomless pit. And therefore it is nothing, right? So we're going to have several different concepts of nothingness in programming, and in particular in C. 0 is nothing, but 0 is also a number, so it's one kind of nothing. Void is another kind of nothing. We'll have null, and we'll also have a couple of other things that may mean nothing in different contexts. In this context, though, void means that you don't have an output or you don't have an input. A function that does not return a value is a void function, and you specify void as its return type. Right? A void function, in a void function, I should say, you should still have a return statement, but return nothing. So we've seen this before, this syntax at least. Oops, return, spell it right. There we go. There, return and then semicolon. What's between the return and the semicolon? Nothing. So you're returning nothing, right? It's a void function. You return nothing from it. You can also have a function that takes no inputs. Right? Just like in mathematics, you have a function that takes no inputs. You have a constant function, say a function 5, right? And then you would graph that as a horizontal line, as a constant function that doesn't change regardless of the input because there is no input. Let's just take a really quick look at the syntax here. Void swap int a and b. This is going to be an example that we're going to actually use here today. Int b. There. This returns no value, right? It doesn't have a return value because you specified the return type here, void, as nothing. It doesn't return anything, right? Obviously, the point of this function, or the purpose, or what this function is going to try to do, is you give it a and b, it's going to try to swap those values, right? And it's not going to have anything to return to you because it's just manipulating stuff, right? And we're going to find out why it fails here by the end of the day, though. Int void, or sorry, you can't have a function named void, but I'll just call it foo, right? Here there's a function with no input, right? Strictly speaking, this is not absolutely necessary. Instead, you can omit the keyword void in this particular instance of foo and then void. Or instead of actually typing void, you just put in empty parentheses. Because if you've got what's between those empty parentheses? Nothing. So it also means void in this case. There is a slight subtle difference that you would only really care about if you're using older compilers or if you want to be really pedantic about things. The first one is an explicit declaration that it takes no inputs. The second one is it may or may not take any inputs, but we're going to ignore them. And the compiler does certain things under certain conditions. I would encourage you to go with the second style here, though. If you've got a function with no inputs, just have empty parentheses. All right? There would be people that would disagree with me, and that would be a healthy debate, but I'm not going to dwell on it too much. All right? Another item is function overloading. All right? So how do you compute the absolute value in C? Right? How do you do this? What function do you use, and in what library is it? Abs, right? So let me bring this over here, increase the size. Let's read the manual about it, RTM. Man abs. Right? It's in the, well, that one's in the standard library. Ooh, wow, that's surprising. But it's nevertheless a math function, abs. Well, it only works for what type? Integers. What absolute value function do you use for doubles? Fabs. That, turns out, is in the math library. And it's not alone. You also have fabsl for long doubles, fabsf, which is for floating point types. You also have labs. You also have in the standard library labs for longs. You also have labs in the standard library for longs, right? So I wasn't counting, though, but we have probably half a dozen or more different function names that do the same thing. They all do the absolute value function, right? Why do we have so many different functions with different names that do the same thing? So there are at least 6 different absolute value function, one for each numerical type, right? And again, we only focus on integers, doubles, and chars for this course. But of course, there are a lot more types that you can use. In C, if you give a function a name, that is the only function that can exist with that name. Right? With that name. Just like if you give a variable a name, int a, there can't be 2 variables in the same scope with the same name. Here's a variable a, here's another variable a. Int a and double a, right? Those are 2 different variable types with the same name. You can't do that because you can't disambiguate. Well, okay, a plus b. Well, which a do you mean? Likewise, if I try to call a function, the absolute value function in C, right? Which one do you mean? Do you mean the one for integers? Do you mean the one for doubles? Do you mean the one for longs? The compiler doesn't know. The C is a programming language that does not support what's called function overloading. Some languages allow you to have multiple functions with the same name that operate on different types. Right? Say int versus double. Right? This is known as function overloading. Right? You're overloading what the function does, right? That's what you're overloading it with more than one meaning. C does not support that. C does not have a function overloading because C is not an object-oriented programming language. Function overloading is an idea that came out of object-oriented programming paradigms like C++ supports it, C#, Java. Basically, any object-oriented programming language, modern object OOP language will support function overloading. But the way that it does it is exactly the same. If you, when you learn Java next semester, say, if you continue, then you'll find out that there are actually 4 or 5 different absolute value functions in the math library in Java. The only difference is that they're all called abs. Whether or not they operate on longs, integers, doubles, whatever, they all have the same name for convenience, right? It's a convenient thing, but also it's because it's an object-oriented programming thing. It uses what's called static dispatch at compiler time. The compiler says, all right, you wanted to call an absolute value function. Which one of these functions did you actually mean? What type did you give it? Oh, you gave it a double, so you probably meant that one. And then it makes that determination for you. C does not do that. C is not going to play a guessing game with you, and it's not going to allow you to let it do what you think it might do best. So it simply the design of C doesn't allow you to do this. Instead, if you want a function, an absolute value function, to operate on doubles, you need to give it a different name. So we've got fabs. If you want it to operate on longs, you need to give it a new name, labs, right? So basically, without function overloading, you need a different name for every variation of your functions, even if they do the same or similar things. This can very easily and quickly lead to what's called namespace pollution. And namespace is actually one word here. Let me correct that. There we go. Namespace pollution. By every time that you create a function, you pollute the namespace. Sometimes you need to create functions, so sometimes namespace pollution is necessary. But if you go and write a function after function after function without really thinking of your overall design, basically you're stealing all of these names. Once you've created a function that, say, you call it distance, no other function can have that name. And now if you need to disambiguate it and say, well, I meant Euclidean distance, or I meant air distance, or I meant something else, now you need another function with a different name. So think before you name your functions, because once you've named something, you can't use it anymore. That's not that big of a deal if you're just writing your own small little programs. But if you're bringing in a library here, another library over here, maybe some code that you found on the internet over here, and a library over here, what if we had namespace pollution, and in this library, they had a function called distance, and in this library, they also had a function called distance? You can't use those libraries together very easily anymore. So the way that that's generally avoided is if you're going to write a library, you prepend things with library-specific things. Later on, we'll take a look at a library called GTK, which is GNU's or the GIMP toolkit that allows you to write graphical user interfaces. The library is called GTK, so every single function in that library starts with a GTK. It's because they don't want to pollute the namespace. Now, if you brought in another library that had a function that also started with GTK, well, now you're back at the same problem. But by prepending every function with GTK, they're kind of reserving that namespace for themselves. So it is something that that you may have to experience eventually, namespace pollution, and it's because it doesn't allow function overloading. Right? Finally, the last bit of miscellaneous stuff is how do functions actually work, right? So this is going to require us to dive a little bit deep into how an actual computer program works at a much lower fundamental level. Before we do that, let's understand a very simple data structure called a stack. Programs have what is called a program call stack, which is a LIFO, that is last in, first out data structure. Right? To understand what I mean by that, and I'm not going to be able to draw a nice picture here, but imagine a stack of dishes. Right? Here's a large stack of dishes. Now, if I just washed a dish and I want to add it to this stack, I want to add it to this pile here, how should I go about doing that? Should I shove it in at the bottom? What's going to happen to that stack? It's going to fall over and all the dishes are going to break. Should I try to shove it into the middle somewhere? Probably not, because of the same problem. Where's the only safe place to put this dish? At the top. We call this the top of the stack. And putting something on top of the stack is called pushing. You push on top of the stack. Now, the opposite operation. You want to take a dish off because you want to go ahead and eat your meal. Should I pull that dish out from the bottom? No, of course. Not well. If they're all plastic, then you don't care. But then you got to pick them up anyway, right? So take it off the top.